Hello, William Rose here. I'm just doing the follow-up to my final Module 9 lab today. So today I brought the recap into my little home office area. I did perform the lab down in my garage. Had the same safety procedures as always. I have 3 exits, fire extinguisher. There's no chemicals involved this week, but as always, I have my garage outfitted for pretty much anything you can need, spill response, fires. That's pretty much it. I also have my own laser etching and engraver, so I actually have like a dedicated spot in my garage for lasers. And then I have all the PPE and stuff like that. This week we utilized a laser pointer in order to measure the wavelength within the light. And so with that, basically I'll go through kind of what we did. And so, going into the lab, my idea or my hypothesis was that we would measure the individual wavelength of the laser pointer, and then we would have the measurements. We'd be able to calculate the wavelength for that specific laser pointer. I went into it knowing that red coloration has a specific range wavelength of, I had it written down, 630 to 670 nanometers. So I figured I had to be somewhere in that range. And I was very close, given the looseness of my measurements. I used a ruler rather than calipers. So there's a little bit of deviation there, but I'm still very close to that coloration range. So for this one, we basically set everything up. We set up our diffraction grading, and then we took the wavelength, then we took measurements and calculated our wavelength. So when I was looking at it, basically I had my imagery here. So I had the main dot, I had the first order, what do you call that, the diffraction here, which to me indicates that basically it's the maxima. So we look at a wavelength, I guess it'd be something like that. And so our first order would be here and here, indicating that this is what I guess would be lambda, one wavelength. And given the red coloration, should be somewhere in the range of 630 to 670 nanometers. And so that's basically what I got there. Obviously, full intensity was at the main point. The first order lost a little bit of intensity. I did have pretty good perpendicular line of sight, and so I had about 3.5 centimeters or 35 millimeters between the first order and the main. And then for the second part, I had the flashlight, which hopefully you can kind of see with there's a shadow, but it goes through the whole spectrum of the coloration, which was pretty cool. Also had the disc, which we shined the flashlight on, and you had the individual wavelengths that you could see in each specific quadrant. So overall, success on that one. I'll show some of my values though. So I had the 35 millimeters between the first order and the main. Length of light, I had 238 millimeters. And then I did have to kind of dissect this a little bit because I wasn't sure what step 1 was talking about for a D, space between the lines. So I kind of reversed it, given my known coloration spectrum, and then what I had for X and Y, and then kind of reverse engineering it. And I ended up utilizing for D the 238 millimeters, which got me in a wavelength of 618 nanometers. So close. You're getting closer to orangish coloration, but like I said, given that I had a kind of a looseness for measurements using the ruler and not like a pair of calipers or something, I think that's adequate. And so then for the second part, we went into Skittles for modeling the half-life. And so with that one, basically you flipped over the Skittles, whichever ones had the S on top, that was considered the parent, the S down was daughter, and then basically we repeated that test until I basically had no more parent atoms left. So I got to my 6th test of that before I ran out of parent atoms, and then basically indicating that all the daughter atoms had decayed, and the test was done. So now, after this, after my video, I'm going to go in and I'll do the Excel graph and do the half-life on the x-axis, percent radioactivity isotopes remain on the y-axis, and then I'll upload that along with my individual images. So overall, I think the labs were a success. It's the last one for the class, so thank you. And hopefully I did everything correct.